So we're going to continue with section 4.4. This time we're looking at matrices. So while we were big mean teachers who made you learn how to solve these systems algebraically, there's actually a much simpler way you get to do it, and it's called using a matrix. So a matrix is a rectangular array of numbers enclosed in brackets. They're referred to by their size. It's m by n, so m is the number of rows and n is the number of columns. So a system of three linear equations is written in a 3x4 matrix by first rearranging the equation so all of the variables are to the left of the equal sign and the constant term is to the right. Each row now corresponds to an equation. You enter the coefficients of the variables in the equation as the first three columns in the row. In the first three numbers in the row, and then the constant on the right side is the fourth number. So based on this system, 2x plus y plus 3z equals 20, 5x plus 2y plus z equals 21, 3x minus 2y plus 7z equals 9 is represented as the matrix 2, 1, 3, 20, 5, 2, 1, 21, 3, negative 2, 7, and wow. Looks like they made a mistake there. I'm not sure what it's supposed to be. It's either 9 or negative 9. Whatever they decided it's supposed to be, that's what it's supposed to be. You take the coefficients in front of the variables. One key thing is to make sure the variables are all in the correct order. So make sure all the x's are first, y's are second, and z's are third. Now you can actually solve these by hand. You might see that in the homework key if you look at mine, since I did all mine by hand. It's essentially they do a process of multiplications and adding of rows. That is a method of using elimination, but we actually can just use our calculator because our calculator will do it for us. Makes things nice and easy for you. So first thing I want to talk about is what a solution looks like. So we've talked before about what it means to be a solution to a system of three equations. A solution would either be a point, it would be no solution because the planes don't intersect at all, or the answer would be a line, in which case there would be infinitely many solutions. So once you solve your matrix using your calculator, you've got three different options on what your answer will look like. The first one will look like this. And you'll have some numbers there, A, B, and C. Now, when you get your answer like this is essentially the equation 1x plus 0y plus 0z equals A. So essentially, x is just A. Your x value is whatever the number is that it gets there. And then essentially this one is y is B and z is C. So this is your answer where your solution is a point. So you write it as the ordered pair A, B, C because those are the numbers for your point. You might also get a solution that looks like this. So you'll notice the key here is in the bottom line. This is essentially the equation 0 equals 0. Now, because that is a true statement, that means this one has infinitely many solutions. You would essentially make a line. And then your last option on what a solution would look like, let's make that a 1. You might get something that looks like this. Now, again, we're noticing the last line. This will get an equation that 0 equals a number. So since this one is not a true statement, this is when we'd have no solution. So if you get 3 ones and 3 numbers, you've got one ordered pair solution. If you look at your last row and you get 0 equals 0, infinitely many, if you have 0 equals a number, that's when you're going to have no solution. So we just want to, at this point, write as a matrix, and then you'll have to watch the other video to show how to put it in your calculator. First thing we want to check, make sure all the x's are first, y's are second, z's are third. They are. So now we can just take the coefficients and write them in our matrix. So looking at the first equation, coefficient in front of the x is 1, in front of the y is 2, in front of the z is 3, and then 9. Second equation, 1, 3, 2, 5. Third equation, 1, 4, negative 1, and then negative 5. And once you plug this into your calculator, you should get this as your solution. So again, the first number represents your x, second is your y, and z is your third. So your solution is the ordered triple 2, -1, 3. So you have to watch the video or pay attention in class on how to do what's called reduced row echelon form to solve these in your calculator. But we're going to just focus on what our answers look like and how we plug it into the calculator. So again, we're going to take the coefficients. So in our first equation, we have -2, 1, 3. You'll often see me, I put a little dotted line, just helps me differentiate what's the equation and then what's the solution. So -2, 1, 3, 20. Second equation, -3, 2, 1, 21. 3, -2, 3, -9. So this is our matrix. As you'll input it into your calculator, this is your solution that you'll get once you do reduced row echelon form. So since we've got 3 ones, we've got 3 numbers, our answer is an ordered triple, -4, 3, 3. Let's do another one. So let's figure out what the matrix is. We'll put into our calculator, looking at the coefficients. 1, 2, 1, and then 8. 2, 1, -1, 4. 1, 1, 3, 7. Once you solve it in your calculator, your output should be this. Whoops, that should be a 1. 0, 0, 1. 1, 3, 1. Since we have 3 ones and 3 numbers, our solution is an ordered pair, 1, 3, 1. So moving on to word problems. The hardest part about these is, as usual, coming up with the equations yourself. So make sure you're paying attention to what you are calling your variables, stuff like that. You can look at that one yourself. We're going to try one together. All right, so we've got some basketball player. He's got so many points scored on 2-point baskets, 3-point baskets, and 1-point free throws. So that's probably going to be, well, if we read our last line here, how many different types of baskets did he make? So I'm going to say X is the number of 2-point baskets. Y is the number of 3-point baskets. And Z is the number of 1-point free throws. So let's check out what our equation should be. First thing is total points scored. So total points scored. Now notice our variables represent how many baskets are scored. So that's not how many points, which means we'll have to take how many baskets multiplied by the amount of points. So since X is the number of 2 points, if we multiply 2 points times the number of baskets he made, that'll tell us the points. So we should end up with 2X plus 3Y plus 1Z equals his total points scored, 13,726. In his career, he made 2,144 more 2-point baskets than free throws. So that means his number of 2-point baskets, that's X, should be his number of free throws, that's Z, plus 2,144. And 1,558 more free throws than 3-point baskets. So that means his number of free throws, that's Z, should be equal to 3-point baskets, that's Y, plus 1,558. Now from here, you could solve this pretty easily by substitution. But since we're working with matrices, we probably should write this as a matrix. So make sure in order you do that, remember it has to go X, Y, Z. So that means we'll have to rewrite some of these equations. So we'll have to move that Z over here. There's no Y's. And similarly with this one, this time we've got no X's. We'll have to subtract the Y. And then add that Z, 1,558. We'll finish this here in just a minute.